You talk about dopamine, focus, and motivation, and how to manage our dopamine hits, because it seems like every 30 seconds we're getting dopamine now, whether it's drinking coffee, having candy, social media, email pings, dings on the watches, whatever it is. It's a dopamine overload, it feels like.
Yes.
So how do we stay motivated and manage dopamine at the same time?
Yeah, great question. So dopamine is the molecule of motivation. And
the molecule of motivation.
Absolutely. I mean, for years and years, people thought dopamine was about pleasure, but dopamine is mainly about craving and motivation and drive. So here's the experiment. Take 2 rats.
Yeah.
You give them a lever they can press, and they can get food out of that lever. They can get heat if their cage is cold. They can get all sorts of things that are great for a rat, including a mate to mate with if they press this lever. Both rats press the lever just fine. Now you take away dopamine from one of those rats. You can actually do that by using a toxin that can kill off all the dopamine neurons. Okay. There's an equivalent experiment that's been done in humans, but it was a naturally occurring death of these dopamine neurons, much in the same way that Parkinson's destroys dopamine neurons. What you find is that both rats or both people still experience pleasure from food, from sex, from warmth when they're cold, from cool when they're too warm, etc. However, if you take that rat, both rats, and you move them 1 rat length away from the lever, so they have to just do a little bit of work in order to press the lever. Or you take a human who has no dopamine neurons or very little dopamine, and you make the pleasureful thing a little bit more challenging to get to. The ones with no dopamine do not pursue pleasure at all. That's just one example of what now are hundreds of examples in the neuroscience literature showing that dopamine is the molecule of pursuit, craving, motivation, drive. Pick your favorite word.
So dopamine is a good thing in motivation.
Provided it's in proper levels,
right.
Yes,
okay.
That's right.
Okay.
If your dopamine is depleted, you will feel not motivated. Now, there's a double-edged sword here because many things, as you mentioned accurately, trigger dopamine release. Look, seeing a positive comment, a compliment, food, the more palatable a food, a really tasty chip compared to a slice of a potato that's baked but doesn't have anything on it, one truly releases more dopamine than the other.
Right.
I could list off a number of things, but we have a baseline level of dopamine. Nicotine, for instance, increases that by about 50%.
Gives you more dopamine.
More dopamine is released. You have 2 major dopamine pathways in the brain. There's one related to movement, one related to reward. So nicotine, about a 50% increase. Cocaine, 100% increase, a doubling. Methamphetamine, 1,000 or even 1,000-fold increase.
Holy cow.
So huge increase in dopamine.
That's why it's so addictive.
So addictive, but what happens after that big dopamine increase is that the baseline levels of dopamine go below what they were before. How low that drop is below baseline is proportional to how big the increase was before.
That's why it's so addictive to stay on these things.
That's right. Well, and that's why if you're getting lots of little dopamine hits from things, as we call them, you're going to feel kind of depressed, and those things don't feel as rewarding anymore. Okay, now eventually the system can reset if you don't indulge. So if people are feeling bored, unmotivated, unstimulated, most of the time it's because they are overindulging in things that keep pounding this dopamine system, but the baseline of dopamine is going down, 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 down. Now there are a few hacks that can actually help, and Anna talks about some of these in her book. The main thing is if someone is engaging in any truly addictive behavior or substance, or a behavior that just doesn't feel like it's that great, but you're finding yourself doing it compulsively. But if you allow yourself 4 hours a day on social media, you'll probably find that you're scrolling, you're not even sure what you're looking for.
Like, what am I doing? Yeah,
Exactly.
I just wasted this time.
Exactly. And what you're looking for is something to jolt that baseline. So you want to limit those behaviors, or in some cases, if it gets really severe like it was for this individual, you want to eliminate.
Completely, for 30, 60 days.
Ideally, it's 30 days. Now, this is the same prescriptive that they give alcoholics, heroin addicts, etc. But some of those drugs, of course, have actual withdrawal symptoms that can be problematic. These days, I'm not a pot smoker. I've never liked drugs or alcohol. I kind of lucked out that way. But There's, and I'm not trying to demonize, I'm not passing judgment, but cannabis, for instance, is pretty in prominent use, and a lot of people, the idea of 30 days without that is, I think they probably say they could do it, but it would be very challenging for them. And I'm not here to tell people what to do, right? And there's about drugs, alcohol, or anything, but the idea is 30 days of no interaction with that thing, person, behavior, all sorts of things, so that you can enjoy other things. I like to say, addiction is a progressive narrowing of the things that bring you pleasure. And if I may, enlightenment is a progressive expansion of the things that bring you pleasure.
Right.
All of that hinges on this dopamine system. So you have to be very judicious in your interactions with things that deliver pleasure, or else they will soon not deliver pleasure, and they will diminish your pleasure for everything else that you interact with. So the way to think about this is just to set up constraints. And as I'm stealing Anna's words left and right, forgive me, Anna, she has many more important things to say, and she says them much more eloquently than I, but she says, we don't give our kids chocolate cake for breakfast. But we sort of understand that dessert comes at a certain time of day and after completing certain things. But for some reason, we just allow ourselves to just dive into this immense dopamine sensory landscape of social media. Because social media isn't just comments, you and me saying, oh, like Lewis put something up. There's that stuff's great. But then there's also a lot of violent stuff, politically intense stuff. There's a lot of friction. There's a lot of joy.
Yeah.
I mean, you're essentially going to the dopamine carnival. And and so you need to restrict the amount of time.
Yes.
And especially if you're somebody who wants to get work done and your work is not the social media. And I'm pointing at social media, but this could be anything. Anything that you enjoy. Food, for instance. You don't want to overindulge in highly palatable foods. It's just bad for us. We know this for a number of reasons. So the key is to take this dopamine system and set it up for you to be able to be motivated and focused. And the way to do that is to make the experiences around that thing that you want to be motivated to do a little less or a lot less exciting.
What do you mean?
This is why I don't listen to music these days or check text messages while I'm in the gym. And sometimes I'll listen to a book or a podcast, but I really try and just work out, including while I'm running. Why? Because these days we are layering in dopamine. We're getting dopamine from the energy drink we're drinking. Okay, big increase in dopamine. I forget the actual numbers, but I think it's 1.8 times increase. And some of them have L-tyrosine, which is a dopamine precursor. Some of them have caffeine, which also increases dopamine and upregulates dopamine receptors. So you're getting it from the energy drink. Plus, it's the video game you're playing. Plus, you're with your friends. It's just a dopamine soup, which sounds great, except that other things that you do afterwards are going to seem understimulating. And you're going to think, I can't focus on this.
Yeah.
So I also kind of wonder whether or not you were having trouble focusing in your class because the Canelo fight was that awesome.
It was insane.
It was
amazing.
Yeah, he's amazing. He's amazing. And so I think it may be helpful for people to understand that the postpartum depression that people feel after a big celebration,
It's real.
that's real. And if you just wait a little while, that system will reset. You don't have to necessarily wait 30 days, but if you just had a great party, you should expect that there'll be a long tail of joy, but then you might feel a little low, a little underwhelmed.
So true, man.
And if you're going to sit down and try and do work and you're finding yourself not that focused, you might want to think about some of the behaviors that led up to that work. So I really try to get into my work in a focused way by making the period right before it's a little boring. Frankly, going outside, getting some sunlight, drinking my mate, it sounds like a pretty boring life, right? It's not like blasting a bunch of music and getting really amped up. But I'm able to get a nice peak of dopamine during that work bout. And I think that's a functional dopamine increase. And then afterwards, yes, indeed, there's a drop. Now, there's some other hacks that Anna's talked about. And again, we can look to our friend Wim Hof. Other people have done this, although this was happening long before Wim. There's a beautiful study published in the European Journal of Physiology showing that getting into cold water, so this could be cold shower, could be ice bath, could be any number of different plunge type things or an ocean or whatever that people want to use, for anywhere from 3 to 6 minutes, creates a 2.5x increase in dopamine that lasts many hours. So it's a unique stimulus because it's not like a spike and then it drops. It's like a long arc increasing your baseline dopamine, increases alertness, feelings of well-being. They did blood draws in this study, so these are real data. They weren't.
Yes.
It wasn't conjecture. They really know this, and there are some cases of people who were full-blown addicts or people who are struggling with ADHD who start doing regular cold water exposure, 3 to 6 times a week, 3 to 6 minutes at a time, and discover that, wow, they actually can focus because they're getting that dopamine increase.
Wow.
Yeah.
This stuff is fascinating, man.
It's really interesting. I think that to me, because the dopamine, coming up in neuroscience, I've been in the game a long time now, almost 30 years. But dopamine was always thought of as like pleasure, but it's confusing because it's associated with pleasure, but it's not the actual experience of pleasure. Mm-hmm. And immediately after sex, immediately after any powerful experience that's very pleasurable, dopamine system crashes down. Yeah.
What happens in the body when dopamine crashes?
Well, there's an interesting thing that happens because there's a hormone called prolactin, which is actually involved in milk letdown for nursing, but is also increased in both men and women in anticipation of childbirth. This is actually responsible for the so-called dad bod. Prolactin lays down body fat stores, tends to make people a little more sedentary, and this has been shown in humans and in animals. It tends to reduce libido and sex drive. Mm-hmm. And so if you think about dopamine is a currency of motivation that biology has used for hundreds of thousands of years. So, whether or not, we think about currencies like dollars or euros or bitcoins or Ethereum, all of those actually relate to dopamine. Dopamine is the fundamental currency that we're all working for. And dopamine has this quality of making us focused on things outside our immediate experience. This is why people who are on cocaine or methamphetamine, which is a really extreme version of dopamine increase, they tend to be all about plans and action. They're not sitting there thinking about how wonderful they feel in their own body. Whereas drugs like cannabis and psilocybin and drugs, these are not drugs I recommend people use recreationally. I'm not passing judgment, but I just want to be clear about what I'm saying and not saying. That any drugs that increase serotonin tend to make people kind of still, focused on their internal landscape, their thinking. It's kind of an internal reflection thing. So the serotonin system and the dopamine system are kind of antagonistic to one another. And the prolactin system is associated with the serotonin system. So prolactin is kind of about, it's a mellowing out.
Interesting.
And just to nail the point, there are many people in the world who suffer from schizophrenia, 1% of the world's population, a huge number, a very sad thing, psychosis, hearing things, et cetera. And most of the drugs designed to treat schizophrenic psychosis are drugs that reduce dopamine. And oftentimes you'll see people on the street who are taking these drugs and they'll be writhing like this with their face. Sometimes men will have gynecomastia, they'll have breast development because these drugs block dopamine, increase prolactin, and disrupt the motor pathways that are associated with movement. Wow. I say this for two reasons. One is it illustrates the relationship between prolactin, dopamine, movement, et cetera. But the other is to hopefully invoke a little bit of empathy for people that oftentimes we will see people who, if they're shouting and acting crazy, that's probably an unmedicated person. Who's bipolar or has schizophrenia. But if you see someone in their catatonic or they are writhing and acting very strange, that's a person who's, we don't know for sure, but very likely is actively trying to treat their own psychosis to eliminate the voices and things of that sort. So I say that because we have a big homeless population issue in California and elsewhere too. And oftentimes we see people acting crazy and we think, oh, they're, we make this disparaging judgment, and everyone's prone to doing it, of course, but they're crazy. But oftentimes those crazy movements and the things they're doing are the reflection of drugs that block the dopamine system.
Gotcha.
Yeah. Sorry, I don't mean to make it dark, but I think that there is 1% of the world's population is a huge number. That's a lot. And a lot of people suffering from these things. Yeah.
Now I want to get to how do we spike intentionally? Right. You've talked about we can spike testosterone, but I want to know, can we spike dopamine?
Yeah, so, and you've done this. So your example of craving is actually what you crave. You crave the feeling of craving. Is beautiful because what it means is that you don't allow yourself to go so far down the arc of the dopamine trajectory to get to the other source of motivation. So there are two sources of motivation as it relates to dopamine, and then we can think about tools that we could export from these that are nested in neurobiology. The first is to do what you do, which is to be able to sense the craving as its own form of pleasure. This has
kind of remnants of Carol Dweck's growth mindset that you eventually develop a pleasure in the seeking and the striving. Has has flavors of a David Goggins type approach where it seems like he gets pleasure from the friction itself. And so there are elements of that. You seem to have that as well. But if you can start to identify the craving as its own internally released drug, this thing dopamine, that is a source of motivation, then what you realize is that capturing the reward is wonderful, but attaching dopamine to the reward is actually a little bit dangerous.
Attaching.
Yeah,
this is
celebrating the win more than the pursuit, it actually sets you up for failure in the future. And so this gets us right into something called dopamine reward prediction error. And reward prediction error is basically if you expect something to be really great, and then it's not quite that great, your dopamine baseline lowers. And now understanding what we know about dopamine, that means that not only did you feel as if you lost because it wasn't as much a celebration as you thought it would be, but it also means that you're starting from a lower place, meaning you are less motivated. Now, the simpler way to conceptualize this is, I have a colleague at Stanford, she runs the addiction dual diagnosis clinic at, her name is Dr. Anna Lemke. She has a book called Dopamine Nation that's out right now. And she's really described this pleasure-pain balance, where anytime you have a bunch of dopamine and you're in pursuit, after you achieve a win, now this could be a business win, a relationship, a win of any kind, but inevitably there's going to be a tipping back of the scale on the pain side. And that pain side is always going to go a little bit higher than the dopamine side. So this is what you would feel if you pursued a goal like building a big company. Here it comes, the big sale. And then there's the, well, what now? The kind of letdown. Now, if you simply wait and stop pursuing dopamine for a short while, the scale starts to reset. The problem is a lot of people immediately roll right into the next pursuit. And then what happens is that scale starts to get stuck on the pain side. A little bit more. And pretty soon, no amount of seeking will allow you to experience that craving and motivation. So what does this mean in terms of an actual tool? Well, first of all, if people can do what you do, they're going to be in a much better position in life. Doesn't matter if it's school, sport, relationship, any domain of life. If you can start to register, that craving and that friction and that desire, that almost kind of low level of agitation, sometimes high level of agitation, that is that I'm trying to impose my will on the world in a benevolent way, we hope, that's dopamine. It's working with its close cousin, which is epinephrine, which is adrenaline. They are very close cousins. In fact, dopamine manufactures epinephrine. A lot of people don't know this, but adrenaline is actually made from the molecule dopamine. Okay, so those two are hanging out together. It's like crave and work. And then you get the win. And some people allow the big peak in dopamine to be associated with the win. And smart people learn to adjust their celebration internally, right? This is all internal. You could throw the biggest party in the world, but as long as you're kind of laid back and looking at this, not letting yourself get manic crazy, you won't necessarily crash as hard, and pretty soon your system will reset. So that you take the day, you clean up the dishes, you relax, you go, what now? I'm feeling a little low. Well, rather than going out and spiking your dopamine again, just wait. Understand that the scale will reset again. Give yourself a few days where you're going to feel a little kind of underwhelmed. Things aren't going to be as interesting. It's going to be hard to trigger that big release because you just had the peak. Well, if you adjust that, you relax, you understand there's always a little bit of a postpartum depression. We sometimes hear about postpartum depression. That's a clinical thing, but there's always that kind of, today's not as exciting as the previous days. What am I going to do with my life? But then if you let it start ratcheting up again, then what you realize is your capacity to tap into dopamine as a motivator, not just seeking dopamine rewards, that is infinite. And I can say with great certainty that this is how you were able to build a big company and sell it, how you've been able to build a successful podcast and sell it, how you're constantly seeking, because seeking is the reward. And I think for most people, we think of the reward as the finish line. And so the key is to get to the finish line, step into the end zone, but no end zone dance. It's just like, yep, and now I'm gonna go do it again. That's really the key. That's the key to doing it over and over. And when I see big athletes or academics or anyone or musicians and they rise and crash, it's clear they've lost the touch with the motivation evoked dopamine. And they've lost touch, probably because it hasn't really been described by the neuroscience community until Anna has started talking about this stuff publicly, and I'm echoing what she's beautifully said much better than I am, which is that you should always expect that after a bunch of pleasure, there's going to be that low and then that craving. How do I get back to there again? And the key is you have to walk the staircase again. You don't get to do this as a square wave pull. You don't get to just ascend. It's always up, down, up a little bit higher, down, up. That's the function. So I don't know if that resonates with your experience. If you expect it, that's great, because you eliminate the downside of the reward prediction error. Reward prediction error can also be conceptualized as, I tell you we're going to go to this restaurant, I keep building up the food. I actually raise the expectation and the requirement that food be really spectacular. Better off I just tell you it's going to be pretty good, and then you're wowed by it, right? Because if your dopamine was higher in anticipation than the actual food evoked, well, then it makes sense why you're always integrating over the dopamine release you had previously. Now, there are a couple of things that you said in there that I want to highlight, which I find so interesting, and we can get a little bit Eastern philosophy, mystical here, but tie it back to some real neuroscience, which is, you said, that's the juice. The motivation is the juice. If you look at Eastern philosophy and they talk about qi, and this, what is that? I wager that is dopamine. The desire to pursue things and to create more of oneself and as a species, whether or not you decide to have kids or not, those circuits all use the one universal currency, dopamine, of wanting more things that are outside the confines of your skin. And that's what's driven forward evolution of individuals and families and cultures and our species as a whole. And again, the circuitry's been there for many, many tens, if not hundreds of thousands of years. And so it's highly conserved. And so what that means is that it doesn't matter if it's Bitcoin or Ethereum. It doesn't matter if it's putting rockets on other planets. It doesn't matter if it's building the first automobile. It's the same currency. So understanding those cycles is really key. The other thing is the element of pain. I think that understanding that pain and pleasure are in this really dynamic balance can also help us, which in the following way. Any pain that you feel, the longer day, the less sleep, the kind of agony that things aren't working, that power outlet doesn't work, or the internet is slow, whatever it is, the amount of pleasure that you will eventually experience is directly related, to how much pain you experience. So we know this from actually what nowadays would be considered quite barbaric and unethical experiments, where they would give people electrical shocks and they would measure their response. And then they'd say, we're going to increase it. Eventually they get to the point where a shock that was previously very painful actually evokes a sense of pleasure. Now, you couldn't do these experiments anymore. These are not the experiments I do in my lab. These are older experiments. But for instance, and this has been discussed in scientific research papers, giving somebody a 10-minute ice bath, for instance, or even a 3-minute ice bath, or a 1-minute ice bath is quite painful. But there was a study from the University of Prague, European Journal of Physiology, showed that after a painful ice bath stimulus, the amount of dopamine release goes up for 2.5 hours to 250% above baseline. And that's not because the ice bath itself evokes dopamine release. A lot of people think, cold water evokes dopamine release. No, pain evokes dopamine release after the pain is over. Yesterday I tweaked my back because I do this stupid thing every few years, the same stupid thing, and it's really painful. And then you just remember all the ways in which you can't move around. I was like standing up this morning, I'm like, and just walking is so painful. As the pain has started to dissipate, you get a little bit of a high, right? You get a little bit of a euphoria. That's dopamine, because of the degree of pain that you experienced previously predicts how much pleasure. So when you start a company down in the dregs and you're shoveling again, that's beautiful, because that means that the win that you achieve is going to be as good or greater than the one you had previously, in your case with Quest. And so we go back to this example of the person that's not motivated, that can't get off the couch, that doesn't want to do anything. Well, this is the problem. Remember the rat experiment? They are effectively the rat with no dopamine, but they can still achieve some sense of pleasure by consuming excess calories, by consuming social media. And look, I'm not judging, I do this stuff too, right? Scrolling social media. If you've ever scrolled social media and you're like, I don't even know why I'm doing this. It doesn't really feel that good. And I can remember a time where you'd see something that was just so cool, or you'd see something online. I remember this when TED Talks first came out. I was like, this is amazing. These are some, at least some of them are really smart people sharing really cool insights. And then now that there are like a gazillion TED Talks, I remember spending a winter in my office when I was a junior professor, cleaning my office finally, and binging TED Talks in the background, thinking this is a good use of my time. Pretty soon, they all sucked to me. I was like, this isn't good. So what you need to do is stop watching TED Talks for a while, wait, and then they become interesting again. And that's this pain-pleasure balance. And so for people that aren't feeling motivated, the problem is they're not motivated, but they're getting just enough or excess sustenance. So they're getting the little mild hits of opioid, it becomes an opioid system. And if you think about the opioid drugs as opposed to dopaminergic drugs make people rabid for everything. Drugs of abuse like cocaine and amphetamine make people incredibly outward directed, right? They hardly notice anything except what they want more of, more. It's bad because those drugs trigger so much dopamine release that they become the reward. It's very circular. Only the drug can give that much dopamine. Nothing they could pursue would give them as much dopamine as the drug itself. So there's that. And then there's the kind of opioid-like effects of constantly indulging oneself with social media or with video games or with food or with anything to the point where it no longer evokes the motivation and craving. And this is really the new evolution of the understanding of dopamine in neuroscience, which is that dopamine itself is not the reward. It's the buildup to the reward. And the reward has more of a kind of opioid bliss-like property, which itself is not bad if it's endogenous, released from within. But when we can just sit there like the rat with no dopamine, gorging ourselves with pleasures, so to speak, what you end up with is somebody that feels really unmotivated, and those pleasures no longer work to tickle those feel-good circuits. And so there's no reason for them to go out and pursue anything. And that's a pretty dark picture. So the keys are to pursue rewards, but understand that the pursuit is actually the reward if you want to have repeated wins, okay? The celebration has to be less than the pursuit. And that's hard for some people to do. It's got to be that your celebration is slightly less dopaminergic. It can be very reflective. You can be in gratitude. Those are other neurotransmitter systems, but you don't want to be on that high as you celebrate the win. You want to be trickling out your dopamine regularly until you pursue things. And then just understand there will always be a crash of pain. And the more pain you experience, the more dopamine you can achieve if you get back on the avenue.
It's been a while since I've reviewed the neuroscience literature pertaining to both anxiety and exploration. And so maybe we could start by you laying out what you've discovered and how you're thinking about what you think anxiety signifies, how it's related to exploratory behavior, which I think you described as something approximating courageous approach, although you were talking about mice in that particular paper, and what you're thinking about with regards to the neural basis of these different behavioral responses, behavioral and emotional responses.
Sure, I'd be happy to. And I should mention that these days my laboratory mainly focuses on humans. We still do some mouse work, but we, in partnership with people in psychiatry, we're doing essentially equivalent experiments in humans. So I'd be happy to elaborate there. Many people perhaps, but not everyone, have heard of the autonomic nervous system, which simply means automatic. It's a bit of a misnomer because without going too much into the history of that, if you look back to the origins of medicine in the time of Galen and so forth, when they were first, dissecting cadavers and whatnot, there was this idea of a nervous system, or a portion of the nervous system eventually came to be that could control so-called vegetative functions, meaning that rate of digestion and the really what neuroscientists typically think of as boring stuff. But it's anything but boring. It's the stuff that keeps you from urinating while you're asleep, unless you're a very young child, right? And it's the stuff that keeps your digestion going as you command your attention to other things. The autonomic nervous...
It's all the things that are too complex for us to think through.
That's right. And they are, as you point out, immensely complex. And, nowadays with all this interest in the gut microbiome and things of that sort, these are tremendously complicated operations that are happening generally below our conscious awareness and that are indeed vegetative. They can be controlled by emotion. We were all familiar with the idea that when we are emotionally distraught, that our digestion can be different or et cetera. But typically, we can't control, for instance, in a conscious way, the rate of our digestion.
or the speed of our heartbeat in any kind of direct way. We can have a particular pattern of thought to control those. But in general, those functions were thought to be vegetative and outside of our conscious control. And the name autonomic nervous system sort of swallowed and overtook the vegetative part. So it includes that, but also three main aspects of body to brain signaling. And those three aspects are heart rate, could be quickening or slowing of heart rate. We are and we can be very aware of that, some of us more than others. Gut, and especially the chemical composition and the extent to which our gut is empty or full. So heart, stomach, and then rate of breathing and sort of depth of breathing, meaning how much air we have available to us. And I think the three main ways to think about the way that the brain and body communicate is that it's either going to be mechanical or chemical. Let's use the gut as an example. Your stomach can feel acidic, or it can feel nice and warm and fuzzy, whatever that is in a chemical sense. Your heart rate can feel like it's going at a rate that's appropriate for your circumstances. If you're running, it could be quick. And if you're sitting in a chair quietly at the doctor's office waiting to be called back there and all of a sudden your heart starts racing, then you would think, well, that's appropriate for that situation, but it's uncomfortable, right? It's out of sync with what you are doing, which is sitting. So there's mechanical information, and then there's chemical information. And with respect to your lungs, you can feel like you're out of air or you have plenty of air. You can feel like your breathing is labored or it's easy, or in the chemical sense that the air that you're breathing, your lungs are burning, or it feels easy to breathe. So basically there's chemical and mechanical signaling from the body to the brain, and the brain interprets all of that. And we put all of that under the umbrella of the so-called autonomic nervous system. And the autonomic nervous system can really be best thought of along a continuum. And here I'll avoid complicated nomenclature, but I'll throw it out there for the aficionados. Some people have probably heard of the parasympathetic and the sympathetic. That naming is a little bit misleading. Again, what we can really think about the autonomic nervous system as is a continuum, or more like a seesaw, of at one end is alertness, and at the other end is calmness. Right? That is translated to the so-called sympathetic and parasympathetic nervous system, but I'll call it the alertness and calmness system just for sake of simplicity. So it's sort of like a seesaw, and it has different neural circuits, and basically whether or not you feel very alert or panicked or alert but calm or a little bit of anxiety, that's going to depend on the balance between this alertness system and the calmness system. If you're having a full-blown panic attack, then the alertness system is, it's as if the seesaw is tilted all that way. If you're deeply asleep, well, then the calmness system is really tilted down. You could say that's a portion of the seesaw. This is all kind of obvious, and it dates back, 100 years or so, which isn't that long in the history of science, but we've known this sort of thing for a while. Okay, what's interesting and I think more relevant nowadays is to think about one's own interpretation of those signals and how that relates to anxiety and, as you pointed out, exploration, and then to think about where the nodes of control are. In this seesaw model that I'm putting forward, the seesaw has to include what I would call a hinge, a location in the middle in which you can voluntarily adjust the seesaw to either be more tilted toward alert or more tilted toward asleep. And for many people, they find that their overall level of autonomic arousal is either inappropriate or inadequate for the demands of their life. Inappropriate meaning their heart is racing, they feel more jittery, more as if movement would be the default and worry would be the default and anticipation is the default than is appropriate for their circumstances. Waking up in the morning and feeling stressed, for instance, immediately without any immediate cause, or maybe stress about real life events. For other people, they feel more exhausted than they would like. They're having a hard time leaning into the pressures of daily life. Both of those, even though they have sort of polarized phenotypes, they look very different. In one case, over energized, and in one case, under energized. Both originate within the autonomic nervous system. And we can reliably say from work done in animals and humans that that is not the consequence of the alertness system or the calmness system being disrupted, but rather that hinge in the middle is dysregulated. And we now know what that hinge is. And this is based on work done by colleagues of mine at Stanford, in particular a guy named David Spiegel, who's our associate chair of psychiatry. He's done a lot of work, and his father did a lot of work in the application of clinical hypnosis, not stage hypnosis, but clinical hypnosis for the treatment of various things. But his work and some work in our laboratory now has shown that there's an area of the brain that you are familiar with, Dr. Peterson, which is the prefrontal cortex. and in particular the left dorsolateral prefrontal cortex, if you really want to get down in the weeds about it, that has direct communication with two brain areas that are absolutely critical for this issue of whether or not you feel right for your circumstances, whether or not you translate that into a curiosity and exploration, or whether or not you translate it into this thing that we call anxiety. And those two areas are called the anterior cingulate cortex. Again, I apologize for all the names, but the anterior cingulate cortex and the insula. And I think if I were to make a prediction about what the buzzword is going to be in popular neuroscience in the next 5 years, it's not the amygdala, it's not the prefrontal cortex, it's the insula. The insula has a couple of different regions, but one of its primary regions, the front end, the anterior insula, is responsible for interpreting all those bodily signals. It essentially is a funnel for all those signals about breath rate, heart rate, conditions of the gut, whether or not your body feels ready to move or exhausted, et cetera. And that all funnels into the insula. And then also coming into the insula is information from classical areas like the amygdala, which are involved in threat detection and fear, and also emotion and memory. So the insula is really this incredible hub of information about somatic signals, about bodily signals. And then the prefrontal cortex, the dorsolateral prefrontal cortex in particular, is in communication with the insula and literally makes a...
So let me ask you about that. So does that mean that, so the body in some sense is reporting to conscious awareness? Now it reports unconsciously in all sorts of ways too. So it might report to the hypothalamus, which is a very low level brain control area, by the way, for those of you who are listening. It might report to the hypothalamus primarily unconsciously. But do you think it's the insula that's reporting on the nature of bodily states to the prefrontal cortex in a manner that allows us to be consciously aware of our body states?
That's exactly.
Is that part of that integration system?
That's exactly right. You're exactly right. The insula sits as a different sort of station in that it's reporting to the conscious areas of the brain, to the prefrontal cortex.
Right. So we can take our own physiological state into account then when we're envisioning plans, because part of what the dorsolateral prefrontal cortex does is allow us to envision different possible futures. And those are plans. And you're not going to make a plan to run 2 or 3 blocks to get to the corner store if you're so exhausted you can't get out of bed. And you need a reporting mechanism that tells you what physical state you're in so that you can predicate your plans on that. You think the insula, at least in part, is responsible for formulating those representations or for reporting those representations.
That is exactly right. In fact, the animal data and the human data, both lesion data and reversible inactivation data, support that in humans. So you have that exactly right. And as you mentioned, the prefrontal cortex, it gets sort of thrown out there for everything. I think, nowadays people have probably heard of the prefrontal cortex and people hear about executive function, which of course is true. But if we were to really dial back and say, what is the prefrontal cortex in the position to do? It's a flexible rule-setting structure. How do we know that? I'm sure you are probably more familiar than I am with the classic Stroop task. You give somebody a bunch of cards with different words on them, and those words are written in different colors, and you tell the person, okay, just read the words to me. Ignore the color that they're written in, just read them. And so they're saying they're cat, dog, shelf, book, professor, student, etc. Then you quickly change the rules and you say, you know what, just tell me the color that the words are written in, but ignore what the words say. And people will do that, but there's a portion of time in which they slow down a bit. It's actually hard because you've done a rule switch. Much of life, as you know, and again, this is more your domain than mine, is about applying different rules in different contexts. Now, what we know is that the insula and the prefrontal cortex are both intimately involved in this conversation that establishes which rules are appropriate for a given situation. So for instance, if somebody were to say something that quote unquote triggers me, okay, I'll use myself as the example, right? Maybe someone will tweet something and I'll think, and I immediately want to respond in a way that I know I can kind of flip them on their back immediately. But then I think, maybe I want to refrain from that for any number of different rules or reasons, right? Well, then I'm starting to apply different rules. I'm starting to think about the context that's outside of the autonomic response. Because in a strict, very animalistic way, in other words, in the absence of an insula and a prefrontal cortex conversation, really the only thing an animal or human needs to do is just respond to their arousal in, it's either you can either retreat, you can stay put, or you can fight, right? That's really the only three major.
And those are very fast responses generally. So